So now, today we are going to move forward to 10.2. Okay, the topic will be the Pythagoras theorem and its proof. And there is only one learning target, so please copy down on your class workbook. Okay, I can apply the Pythagoras theorem to find unknowns in a right angle triangle. Okay, so now let's consider a right angle triangle. Right angle triangle. Okay, this is a right angle. Okay, triangle ABC. So opposite to this right angle, this is the longest side of the triangle, and we have the name for it, okay, hypotenuse, which is the longest side. This is very important. We have to find out the hypotenuse for every right angle triangle first. So next, for the small a, which is the base of this triangle, which is opposite to the angle A. And then for the small b, okay, this is the height of this triangle, and then this is opposite to the angle B. And then is there any relationship among the three sides of the right angle triangle? Now we are going to investigate the relationship. So now you can turn to page 11, okay, of your textbook. Okay, we are going to complete the activity 10.1. So now, okay, there are three cases. Okay, for case one, we know that the base of the triangle, okay, which is the base of the triangle, okay, the base is 4, and then the height is 3. Then let's draw it. Okay, then later on we need to measure the length of the hypotenuse. The hypotenuse is 5 here in case 1. So for case 2, if the base is 8 and then the height is 6, then let's draw the triangle. And then later on, we need to measure the hypotenuse. Okay, then the hypotenuse is 10 cm in this case. For case 3, okay, the base is 12 and then the height is 5, and then the hypotenuse in this case will be 13. So now let's summarize our results in this table. For case 1, A is 4, B is 3, and C is 5. And so A square means 4 times 4, which is 16. B square means 3 times 3, which is 9. And then C square means C times C, which is 5 times 5. Okay, so this is 25. So for case 2, the A square with 64, B square is 36, and C square will be 100. And then for case 3, the A square will be 144, the B square will be 25, and C square, which is 169. Okay, and so now let's look at the table. Can you observe the relationship between the A square, B square, and C square? Yes, now we can sum up the A square and B square, and then you can find that it is equivalent to the C square, right? So it holds in all three cases. So this is our Pythagoras theorem, okay? The square of the hypotenuse, which is the longest one, is equals to the sum of the squares of the other two shorter sides. So this is our Pythagoras theorem, okay? So first of all, we need to highlight the right angle. Then opposite to this right angle, this is our hypotenuse, okay? Hypotenuse, which is the most important one and also the longest one, okay? So the square of the hypotenuse, it is on the left hand side. And then later on, for the square of the base, which is the A square, and then the square of B, which is the height square, and then we need to sum them up and put it on the right hand side. Okay, so we are going to apply this Pythagoras theorem to find out the unknown. So example 1. This is a right angle triangle. Okay, so this is a right angle here. So now, can you find the hypotenuse for me? Yes, in this case, opposite to the right angle, this is the hypotenuse. Okay, so this is the longest side in the triangle. We have to take it out first. So x squared on the left hand side here. So for the remaining two sides, we need to make the square of them, and then we need to sum them up. Okay, so this is 15 square plus 20 square. So this is our equation, okay, together with the Pythagoras theorem. So by solving the equations, then we can find out the value of x. So how? We can see that we are finding x, we are not finding x squared. So we need to remove the square from the left hand side. So which symbol or which sign can we use in order to cancel out the square? Yes, that is the square root. So we are going to uh, draw the square roots, okay, on both sides to make the equation balance. So on the left hand side, the square root will be cancelled out with the square, right? So it shows the x on the left hand side. And then on the right hand side, first of all, you can calculate the number inside of the square root, and then this is 625. And then later on, when you take the square root of it using your calculator, then it is 25. Okay, so you solve for the x already. Example 2. So once again, this is a right angle triangle. So can you find the hypotenuse for me? Is it y? No, because y is not opposite to the right angle. In this case, 26 is our hypotenuse. Okay, this is our longest side in this triangle. So we need to take out the 26 and make the square of it. Okay, and then for the remaining two sides, the y and the 10. Okay, so we need to make the square of them, and then we need to sum them up and put them on another side. So this is the Pythagoras theorem. So now, how can we solve for the y in this case? First of all, we need to single out the y square on the left. So we need to remove the 10 square. So we have to put it on the right hand side. So 26 square minus 10 square. And then later on, we need to handle the square of the y here. Okay, so we need to create a square root. Okay, so that the square root will be cancelled out with the square. Okay, at the same time, on the right hand side, you can calculate for the sum or calculate for the difference. Okay, so which is 576. So when you take the square root of 576, then you can solve for the y. Okay, y will be 24 in this case. So now, can you find the unknowns in the following figures? Tips for you. Okay, always find the hypotenuse first. So for part A, since this is a right angle, so opposite to the right angle, this is the A, so this is the hypotenuse. So we always take out the hypotenuse and single it out on one side, and then on another side, we have to combine the squares of the remaining two sides, okay, by the additions. So by taking the square roots on both sides, then we can find out A will be 29. So for part B, the square, the right angle is here. So opposite to the right angle, this is the hypotenuse. So in this case, 34 is the hypotenuse. So we need to write down the 34 square on one side of the equation, and then on another side of the equation, we need to sum up the b square and the 16 square. Remember to write down the Pythagoras theorem at the last, okay? And then by removing the 16 square to the right hand side, it becomes negative the minus 16 square. And then by taking the square roots on both sides, then we have the b to be 30. So this is the Pythagoras theorem. Okay, so next one we are going to show you how we can prove for the Pythagoras theorem. Okay, let's consider the four triangles and the squares as shown below. Now we can use these figures to form a larger square. And this is the larger square, right? So the base of the triangle is A, the height of the triangle is B, So the hypotenuse is C. And then later on, we are going to move it. So you can see that originally we have the square inside, but now we can turn into the L shape again. So the orange part shows you this square. The area of this square will be A times A. The area of this square, which is B times B, right? So now, if you compare, this is our original figure, this is our new figure. The area of the orange part should be equal. So, as you can see, for the left-hand side, the area of the square, which is C times C square. And then for the area of the orange part on the right hand side, which is A square plus B square. So we can see that C square equals to A square plus B square. And so this is the proof. Besides this proof, there are two other proofs on your book. Okay, so you can refer to your textbook to find out the two other proof for the Pythagoras theorem.